Hello, welcome again. We are covering subject compressible probe for IAS, IFS and Gate Aerospace Engineering. So we have covered first topic, that is introductory part, and in this topic we covered definition of compressibility. Okay, now the next topic is flow regimes. So now there are four types of flow regime. First is subsonic flow regime, second is transition, third is supersonic, and fourth is your hypersonic. To discuss these flow regions, first we will consider an aerodynamic body in a flowing gas. So this is your aerodynamic body, or you can say it is air coil, and a gas is flowing over it. Okay. This is aerodynamic body and the gas is flowing over. So far from the body, the velocity of the gas is v infinity. Okay, so that is your free stream velocity. Okay, so these definition we will consider. This is your free stream velocity, and these lines are your stream lines. These are lines are tangent to the velocity of the fluid. So here the velocity of the fluid or gas is in this direction, so streamline is in this direction. Here it is in this direction, so it is changing, streamlines are changing its direction. Okay. So, and next we consider the Mach number, which is the ratio of velocity of the stream or gas to the velocity of sound. So here these are the definitions that we will consider to define different flow regimes. I am reading these out. To illustrate different regimes of compressible flow by considering an aerodynamic body in a flowing gas, first consider some definitions. First is free stream velocity. For upstream of the body, the flow is uniform and velocity of the flow is called free stream velocity, and it is denoted by v. So this is your body. Okay, and this side is called upstream and this side is called downstream. So here far from the body the velocity is your v infinity, so that is your free stream velocity. Next is streamline. Streamline is a curve in the flow that is tangent to local velocity vector v at every point along the curve. Figure illustrates some of streamline around the body. So here we can see that this is the streamline because velocity is in this direction and streamline is straight. So as it flow over the air coil, the direction of velocity is changing. So streamline direction velocity, here the velocity is in this direction, so streamline is in this direction. Here the velocity in this direction, so it is. So as the velocity of the direction of the velocity changes, the velocity of the direction of streamline changes. So at this point the velocity is in this direction, so streamline is in this direction. At this point the velocity is in this direction, so streamline is in this direction. So these are the streamline that is tangent to velocity vector. Next definition is speed of sound. The speed of sound in a gas denoted by A is a thermodynamic property which vary from point to point. So speed of sound is there are different speed in different medium. In liquid the speed of sound will be different, and in gas it will be different, and in solid it will be different. So speed of sound in gas is now here it is considered, so that is your speed of sound. It is a thermodynamic property and vary from point to point as the Mach number varies, because Mach number is defined as the ratio of velocity of gas to speed of sound. Okay. So this depends upon the temperature of the body of the fluid. Okay, so it will vary. So speed of sound in gas is a thermodynamic property because formula is root gamma RT. So R is characteristic and exponential T temperature, so it is thermodynamic property, so that will vary and it is defined as root gamma R. the speed of sound in gas. So it will vary from point to point. So next definition is Mach number. The Mach number is defined as the ratio of velocity of gas to speed of sound. So if we consider here the Mach number is n infinity. So this is your free stream Mach number, and here at each and every point the Mach number will change. So that is called local Mach number. So m infinity is your free stream Mach number, that is velocity here and speed of sound here. So here temperature is different, temperature of gas is different, here temperature of gas is different. So A infinity will be your gamma R T infinity root this, and A will be your gamma R T root here for temperature T, and here temperature T infinity. So it will depend upon the temperature. A infinity will be different, A will be different. Okay, and V is velocity here, A is sound velocity here, here V infinity is velocity here, and A infinity is sound velocity here. Okay, so there are two types of Mach number to define flow region. First is free stream Mach number, that is V infinity by A infinity, and another is local Mach number, that is varying from point to point, that is V by A. So M simply will be used to define 4 different flow regimes in fluid dynamics. So now in the next video we'll study the different types of flow regimes, and these properties will be helpful to define these flow regimes: free stream velocity, streamline, speed of sound, and Mach number. So we have related free stream velocity and speed of sound with a single number, that is n infinity. So generally m or and local speed of sound and local velocity with m. So these are generally Mach number is generally used to define different flow regimes. Okay, in the next video we will study these different flow regimes that is there in fluid dynamics.